Okay, I'm doing problem 9 from chapter 18. The problem reads, consider the circuit shown in figure 18.9. Find A, the current in the 20 ohm resistor, and B, the potential difference between points A and B. Okay, so the diagram was kind of confusing me, so I redrew it. I made the battery at the bottom here, and then I also made the parallelism more obvious. It's this. And I added the 20 ohm. So this right here, that's also this. I just added those to make it 25. Okay, and then I simplified that by making this one resistor. So to do that, it's parallel. So it's each of the little ones, the inverse, and then the inverse of that. And this was 2.94 ohms. So that's where it is here. And then I added that plus that to get 12.94 ohms. So this is the most simplified version. Okay, and then it's given that there are 25 volts. So first, I'm going to find the current for this using V equals IR. 25 equals I times 12.94. I equals 1.93. Okay. So if it's series, then the current applies to each. It doesn't split. So I know that this has 1.93 and this is 1.93 as well. And this is 25 volts. Okay. But this 1.93 goes to here and it splits because it becomes parallel. So instead, I'm going to need volts for this because volts doesn't split in parallel. So I'm going to use V equals IR again to find the volts of this resistor. Okay. And that is 5.68 volts. So label that there. And this is 5.68 volts for parallel. V total equals V1 equals V2 equals V3. So each one of these is 5.68 volts. Okay, now the question asking for the 20 ohm resistor. So I'm going to split this one up and make it bigger. So it looks like this. Okay. This is 5.68 volts. This is 20 and this is 5. Okay. So I have to go back to current because the volts split for each resistor because it becomes a series. This is no longer parallel because we're just looking at this. So I'll use V equals IR, where R is 25 ohm because it's both of these. So 5.68 volts equals current times 25 ohms. I equals 0.23 amps. Okay, and current does not split in a series. So this one is 0.23 amps and this one is 0.23 amps. And the question is asking for this. So the answer is 0.23 amps to part A. Okay, and then part B is asking for the potential difference between points A and B. Going back to the diagram, A and B are before and after the parallel. So it's from here to here. And that's the same as this. And we already have the potential difference, which is the number of volts. So it's here, 5.68